Okay, in this video I want to show you how to use the open timer function to record how much time a piece of code takes to complete. You might recall that we have this function open timer 0. We're using timer 0. The three settings we want to mention a little are timer 0 source internal, timer 0 16-bit counter, and the timer 0 1-to-1 prescaler. Now, when I say timer 0 source internal, I'm going to be using the internal clock to count time. So the chip, which is operating at a default 1 megahertz, has a 250,000 hertz clock. So every one instruction cycle, it generates an edge, and we can count those edges. We're going to use a 16-bit counter. That means our counter can go from 0 to 65535. You could also use an 8-bit counter, but it only goes from 0 to 255. And we're going to use a prescaler of 1, which means count every edge while we're doing our timing. Many other values of n are available, like 2 and 256 and 32, as mentioned in the previous video. So I've set this up so that I can communicate. Here are the three lines of code that I wish to measure, to time. It's hello world, a delay of 50,000, and a delay of 100,000. Now the way I time these guys is in front of the code, I initialize timer 0. That is, I set the flag to 0 and I rate the timer as 0. Then when I'm finished, I simply read the timer and record the value of the flag. Remember, the flag overflows if I exceed 65535, since I'm using a 16-bit timer here. And I'm going to copy that for each of these lines of code. Copy, down, same thing. Don't need this anymore. In each case, I want to print out how much time it takes, right? So I got three lines of code. I'm going to measure each of the lines of code to see how much time it takes. Okay, so I am going to build the code and launch it and put it. So it's building, Here's hello world. Here's hello world. And here are the three lines of code. So let's go back up here and look at what the results are telling me. So it said that the counter in read timer only got up to 3451 for this. Okay. The next line of code says delay for 50,000 units. You can see here it actually delays for 50,002. That's correct because it takes at least 1 unit of TCY for the rate timer to work. This went for 50,000, and then the next instruction cycle, this gets read. So being off by 2 is fine. We don't normally have to correct for that because 2 instruction cycles is normally very small. Pay attention, though, to this guy when we did the 100,000. Read timer can't go up to 100,000. It went up to 65535. The next time it started over at 0 again, and the flag went from 0 to 1. If I look at this and add 65536, so 65536 plus 34466, I in fact get 100,002 instruction cycles, which is what expected. Right? So this flag, I can keep track of the rollovers and actually exceed the 65536 limit on my counter. Now let's try something different in the code. I'm going to come up here and I'm going to change the prescaler to 2. So let's build the code and program it and see what we get. Still programming. These things are kind of like noise occurring here. But here's the result we want. The results for after it fully loaded. You'll see that the amount of time, 1725, is half of what we had before. 25,001 instead of 50,002. And for the second one, we no longer exceeded the flag. So we can use n to figure out how much time, right? So these guys have a prescaler of 2. So to get the correct number of time that's come by, I have to multiply by the prescaler here. So that brings us to how do we measure time? Okay? Well, how do we convert the numbers we have on this screen to actually how many instruction cycles have actually passed and how many seconds that is? So let's look at how we do that. So here's the timer flag. Right? So if I look at this, the duration in TCY, right, is going to equal, well, whatever the timer 0 value was. I misspelled timer 0. But I have to add 65536.0 for the flag. So the flag going to 1 means I've overcounted 65536. And then I would have to multiply it by n, whatever the prescaler is. So right here, it would have to be 2. Okay. And so that's the amount of time in TCY. I'm going to leave some space for that up here. And I'm going to make it a float because it's easy for me to exceed the amount of time, the maximum integer values. And once I have this, how do I get it in seconds? Well, if this is the number of TCY, right, 1 TCY, right, is equal to 4 over F us. For that, that's 1 over 4 million. And that's, that's 4 over 4 million. Using the formula we used before. And that's 1 e to the minus 6 seconds. Okay. 1 e minus 6 is the same as saying 1 times 10 shifted to the minus 6. Okay. But this is how you write large numbers in C. So, if I want the duration in seconds, I take the duration in TCY and multiply it by 1e minus 6. And we'll print those values out. Print f slash n slash r, and that's going to be, we want TCY equals percent f seconds equals percent f. We want the variables. That here, and duration in seconds. Here. Finish with a semicolon. Go up here and make duration seconds correct as well. And for each of these, so that's hello world. Okay. Let's see. I just want to make sure I can see clearly what I'm doing. I'm going to make a little change here. I'm going to come up here and I'm going to play around with the prescaler a bit, so I want to make sure I'm getting this correctly, so using prescaler instead. And here. And here. Let's hope I haven't made any mistakes. And I'm going to try compiling this. Boring bit is always waiting for this to work its way through. Let's look at the code. Some noise here. It's programming. Okay, so you can see it gives me the correct number of TCY and converts them into seconds. Each TCY is 1 microsecond, so 50,000 microseconds is 0.05 seconds. So that's working nicely. I'm going to come back up here. I'm going to change this prescaler to 1. And so I want to change that to 1 and do it again. Make sure that my code is correct. That I have this formula correctly written down so it's not making any mistakes. So the build is good. Now it's going to the programmer. Okay, so the last one that comes up, that'll be my correct value. Right? And you can see that the last set matches the set before. So I do have, in fact, the correct formula right here for rating the time in TCY and in seconds. So when you use this, you have to know what's the operating frequency you're using and make adjustments appropriately, and which prescaler you're using. One question here is then, so what's the maximum value in TCY that you can time for? Well, this goes up to 65535, right? So basically 2 times 65536 times the prescaler in TCY, whatever that is. Okay. And in seconds, the same thing, just multiply it by FOSC. That's all for now. Thank you.